Hiya, Mr. Green here. I'm here to take you through the next lesson of the physics topic electricity, and this lesson will focus on resistance. We're going to define what resistance is and use the Ohms Law equation. Could you pause the video whilst you take that down as your title? Okay. First up, as we always do, some retrieval practice. So could you pause the video, answer those 5 questions, and please restart it when you want me to go through the answers. Thank you. Okay then, here's the answers. Question 1. What's the rule for potential difference in a series circuit? Well, the rule is the potential difference splits across the components. So if you've got a total potential difference of, say, 10 volts, and you've got 2 bulbs, each bulb will have 5 volts. It splits equally between them if they are the same resistance. Question 2, what's the unit of current? Current is measured in amps, which is a capital A for the symbol. Question 3, the unit of potential difference. Potential difference is volts. V is the symbol. A series circuit's got 3 components with a resistance of 10 ohms each. What is the total resistance? Well, in a series circuit, the total resistance is the sum of each individual resistance. So the total resistance in that case would be 30 ohms, 10 times 3. Question 5, a little more difficult. A parallel circuit's got 3 components with a resistance of 10 ohms, 113 ohms, and 7 ohms each. What's the total resistance? Well, in a parallel circuit, the total resistance will always be less than the lowest resistor in the circuit. So in this case, the lowest resistor in the circuit is 7. Total resistance will be less than 7 ohms. Okay, so learning outcomes for today. We're going to define resistance, and we're going to use Ohm's law to calculate the resistance of components and circuits. First up, have a look at that image, pause the video, and see if you can write down what you think is happening on there. Okay, just pause it and then come back to us. Okay, so what this is representing is, in the middle you can see the person labelled amp that's crawling through. That represents the current, and behind him is the voltage. That's pushing the current around. The voltage provides the energy to push that current around, and it moves around the circuit. But above there, the person labelled ohm, they're the resistance. And what the resistance is doing is it's trying to restrict the flow of the current. It's trying to stop that current getting through that tube there, getting through the wire. The bigger the resistance, the more he'll tug, the more it'll become smaller, and the more difficult current will find it to get through. If resistance is really high, current will be really low because it won't be able to get through there as easily. The current is really high, that means resistance is low because it finds it very easy to get through. So just a bit of a progress check. Use your knowledge of how current changes in a series circuit to complete those readings. Pause the video whilst you put those answers in. Okay, so as it's a series circuit, the current will remain the same around every part of the component. So every part of the circuit will have the same current. So for number 1, the missing value is 3 amps. Number 2, 1.6. Number 3, 1. Number 4, 5. Number 5, the 2 missing values are 1.4 and 1.4. And number 6, the missing values are 0.9 and 0.9. It's a series circuit. It means that the current stays exactly the same at every part of the circuit. What about voltage though in a series circuit? So if you could pause the video, try and answer those questions and fill in those missing values. Okay, so A, 6 volts is only one component, so it will use all the potential difference on there. It will be 6 volts. B, it starts off with 6 volts. We've got 2 components, and remember, in a series circuit, the voltage or the potential difference splits equally between components. That'd be 3 volts then. 3 or 3 gives us 6. C, we've got 3 components, 3 bulbs, and so the 6 volts will split equally across all 3. 6 divided by 3 gives us 2 volts for each one. For D, we've got 12 volts and 3, and again the rule is the same. It will split equally between all 3. So 4 volts for the first one, 4 volts for the remaining ones. And finally for E, we've got 18 volts at the top, 3 components. It would split equally between all 3, giving us 6 volts for each one. Total resistance of the following resistors. Again, these are in series. So pause the video whilst you calculate those. Okay, so number 1, 1000, 470 and 22, they're in series, so basically we just add them together to make 1492. Number 2, 27, 2215, again they're in series, add them together, 2242. And the bottom one, 3300, 1500 and 47, again they're in series, because it's in series the resistance adds together, 4874. Quick recurrence, what do we mean by current? Current is the rate of flow of charge around a circuit measured in amps. If you haven't got that definition down already, please take it down. Potential difference. What's meant by potential difference? It's the driving force that pushes the current around the circuit, makes it move around. The potential difference is a measure of the difference in charge across a component. So when our electrons, when the charge enters the component, it will use some of that charge to move through there, use some of that energy, and as it comes across it will be different at the end than it was at the start. So then we could work out the difference in charge, the energy that's been used, and that's measured in volts. Finally, what's meant by resistance? Resistance is the opposition to the flow of electrons around the circuit, and it limits the flow of current. So if the resistance in the circuit is really high, the current will be really, really low. It will find it difficult to flow around. If the resistance is really low, the current will be really high. Pause the video and take down that definition. You may have to use it later. Okay, so resistance. It was researched a lot by this scientist here, George Simon Ohm, from 1789 to 1854. He has a law named after him from the research that he did, which is referred to as Ohm's Law, and we're going to be focusing this lesson on the use of Ohm's Law to calculate resistance. Ohm's Law is this: potential difference equals current times resistance. Normally just state it as V equals IR. V is the way we'd say potential difference, I for current, R for resistance. So V equals IR, voltage or potential difference, is current times resistance. Potential difference measured in volts, current in amps, and resistance measured in ohms. And there's the symbol for it, it's the Greek letter omega. So, a couple of examples. First up, a battery supplying the current of 0.2 amps to a filament bulb with a resistance of 5 ohms. What's the potential difference? When I'm answering this in my exam question, I would write out my equation. I would make sure I write it out so it's clear what I've done. So I've got V equals IR. I've then taken out what's my I, what's my R, what's my current, what's my resistance. My current is 0.2, my resistance is 5. If I know V equals IR, then that would be 0.2 times 5. 0.2 is the current, 5 is the resistance, giving me an answer of 1 volt. Example 2. Battery supplying the current of 5 amps to a filament bulb with a potential difference of 10. What's the resistance of the bulb? Again, I'd write my equation out and then rearrange it if I need to. So I've got V equals IR, but looking at the question, I'm working out the resistance. So I rearrange my equation, voltage divided by current equals resistance. From the question, I know that voltage is 10 and current is 1, so that would be 10 divided by 5, voltage over current, giving me an answer of 2 ohms. Finally, a current is flowing through a wire. If the potential difference is 25 volts and the resistance is 3 ohms, what's the value of the current? Again, write out my equation and rearrange it. V equals IR, therefore, current is voltage over resistance. Got my values from the question there. Voltage is 25, resistance is 3. Giving me an answer of 25 divided by 3, 8.33 amps. Be careful with your units, be careful with your rearranging. Okay, on the board there are 5 questions. Please pause the video whilst you answer those and restart it. I will go through each answer. Okay, question 1. Potential difference in a circuit. There's a current of 2.5 amps, resistance of 4. I write out my equation. V equals IR. I've got my current and my resistance. V equals IR. 2.5 times 4 gives us 10 volts. Question 2. V equals IR. I'm looking for a potential difference. Current is 6. Resistance is 15. So that would be 6 times 15. Gives me 90 volts. Question 3. write out my equation and get my values from my question. V equals IR, so that would be 12 times 10 in this case, giving me 120 volts. Question 4, we have to rearrange it. It's asked me how much current the circuit's going to use. So V equals IR, I know V is 30, I know R is 4.5 from the question, but I need to rearrange my equation. Current is voltage divided by resistance. That gives me 30 divided by 4.5, 6.7 amps. Last one in this case, circuit's got an internal resistance of 7, use the potential difference of 14, what's the current? Again, get out the values I know and write my equation down. Voltage is 14, resistance is 7. But then I rearrange my equation again. Current is voltage divided by resistance. That would be 14 divided by 7, giving me a current of 2 amps. Okay, let's do a bit more practice on this. There are 5 more questions on the board there. Please pause the video, attempt those questions using Ohm's Law. Okay, so question 6. We've got our values there. Potential difference is 50, current's 42. What's the resistance? Take those values out and rearrange my equation. If V equals IR, V over I would equal R. So that would be 50 over 4.2, giving me 11.9 ohms. Question 7, we're asked for the resistance again. We've got potential difference of 60, a current of 5. R equals V over I, so that's 60 over 5, gives us 12 ohms. Question 8, a stove uses a power source of 240 volts and draws a current of 5 amps. What's the resistance? Again, we need to rearrange our equation, get our values out first and write those down. Resistance is voltage divided by current, so that's 240 divided by 5, gives us 48 ohms. A dryer's got a resistance of 700 ohms and draws a current of 0.3 amps. What's the potential difference? Again, write my equation out. Put my values in. V equals IR, I is 0.3, R is 700, that would be 0.3 times 700, giving me 210 volts. And finally, a radio's got a power source of 5 volts and operates with a current of 4. What's the resistance? Again, write out all what I know. Rearrange my equation, R is V divided by I, that would be 5 divided by 0.4, giving us 12.5 ohms. Okay, pause the video while you attempt this. It's just a quick exam question. I'll go through the answers once you unpause. Okay, question tells us the potential difference across the 8 ohm resistor. Okay, how do you work out your answer? Well, V equals IR, I is 0.5 and the resistance is 8. I've got 0.5 there from the question. V equals 0.5 times 8, giving us 4, so our potential difference 4 volts. What's the potential difference across X? We can see the total resistance is total voltage is 9. 4 is going across this resistor, so what's left is 5. 9 minus 4 gives us 5. Set of Christmas tree lights is made from 20 identical lamps connected in series. Pause the video while you answer this one. Okay, question A1. The equation that links current, potential difference and resistance, that's just Ohm's law. V equals IR. Calculate the resistance of one of the lamps. So, each lamp's got a current of 0.25 and it plugs directly into the 230 mains electricity. V equals IR, so V over I would give us R. 23 divided by 20, because there's 20 bulbs, means each bulb's got 11.5 volts. R equals V over I. That's 11.5, the voltage across each bulb divided by 0.25, which is the current. Resistance of each bulb is 46. What's the total resistance of the lights? We've got 20 lights, 46 bulbs. That would be 46 times 20, giving us 920 ohms. Okay, very quickly, some multiple choice questions. Pause the video while you answer them and I'll go through them. Question 1, used to current is an ammeter. Question 2, the symbol for resistance is the ohm, it's the omega sign. Question 3, resistance increases, current will decrease. Question 4, Ohm's law. It's the first one, V equals IR. And question 5, it's got a current of 3, potential difference of 5. What's the resistance? Remember, V equals IR, 3 times 5, giving us 15. Hope that was useful. Please review any of the other videos you need on electricity. And thanks for listening. Thanks a lot. Goodbye.